I'm going to record this lesson today, and I'll upload it on the Canvas. Just if you need to look back at anything, it'll be there available to you. All right, so we're going to do 4.1 and 4.2 today. Section 4.1. Our objectives are to read and interpret inequality symbols. You have worked with inequalities before. However, you probably the set builder notation and the interval notation will be new for you. So, our academic standards. So, objective 1, read and interpret an inequality symbol. I know that you know all these. Does not equal to, less than, greater than, less than equal to, greater than equal to. So, that's our first objective today. Our second objective is to talk about graphing intervals. So, look at this now. If an interval extends forever in one direction, it is called an unbounded interval. The following chart illustrates the various types of unbounded intervals and shows how they are described using set builder notation and a graph. So this is saying for the values x, all values of x greater than a, we write it in interval notation. Notice this, a to infinity. And instead of an open circle, I use a parenthesis. Here, greater than or equal to is a bracket. Instead of a closed circle, I use a bracket. Here, less than infinity to negative infinity to a would look like that. X less than or equal to a would look like an inclusive. That's what that bracket is, inclusively from negative infinity to a. The interval from negative infinity to infinity means all real numbers. Okay, so we want to get in the habit of writing in interval notation. I'll hit pause real quick. Objective number 3, this one's straightforward. I don't even need to go over this one. We understand that we can multiply, and we all just need to make sure when we multiply by a negative or divide by negative, you're flipping your inequality symbols. And we know that. Okay? We're going to use linear inequalities to solve problems. And we're going to go into section 4.2, solving compound inequalities. We'll continue using that interval notation. And we're going to talk about find the intersection and the union of two sets. That's solving compound inequalities containing the word and also or. So intersections and, union is or. Academic standards that go with it. All right, so look at this right here. Here's some new stuff possibly. The intersection of two sets is written like this. A intersects B, the set A and the set B. Whereas union is A union B. So there's a symbol that may be new to us in mathematics. Okay? I have a diagram to help us understand that. Look right here. This is the intersection of A and B. All of this is a union, because union means anything of A or anything of B. Do we see the difference between the intersection and a union? Questions? Yes, sir.
Could you show that on a graph?
Could I show that on like a number line graph?
Yeah.
I promise you we're going to get to that. Yeah, trust me on that, Green. It's coming. Okay? So if we look at this right here, when two inequalities are joined with the word and, we call it a compound inequality. It's an intersection. So look right here. Follow me. When x is greater than or equal to 3 and x is less than or equal to 6. So here, x is greater than or equal to negative 3, and when x is less than 6 would be just this area right here. Now what you're going to learn is in interval notation, we're going to finish off writing that as inclusively, maybe, I got to change my ink color to black, that would help. Inclusively, negative 3 to 6 inclusively. That's what, you guys are used to writing it like this. You guys used to write it like this, when all x value is greater than or equal to negative 3 and all x value is less than or equal to 6, right? This is how you wrote it in the past. We're going to write it in interval notation like this. Is that kind of what you're getting to, Mr. Green? Okay, and I'll show you the union. So here is how I showed, look, it was from -3 to infinity, and from -infinity to 6, we're going to go straight to that. So you don't need to write the intersection symbol. We'll go straight to this. However, with an or, we will. Now I want to go over a couple things here. Here it is from -3 to 6. Set builder notation would say all x values greater than or equal to -3 and all x values less than or equal to 6. Okay? Did you guys ever write in set builder notation, or did you just write this? You just wrote this, didn't you? As I already put before, you guys wrote it like this. Right? Okay? So if I ask you to solve a double linear compound inequality, just look up here, what would we do? We would subtract 5 to all three sides, then we would divide by 2, right? Nothing new. I just want to make sure we understand that. Now look at this for the union. This is how you guys would have wrote it in the past. Would you agree? All x values less than or equal to -3, or x values greater than or equal to 2. Would you guys agree with me? You would have wrote it like this. So now look how I wrote it. From -infinity to -3 inclusively, or, that's a union symbol, inclusively 2 to infinity. So this is a completely new concept for us. And I have some examples that we'll practice together of writing it. Okay. All right, so let's get to it. Right to it. Here we go. So if I ask you to solve and graph this is just a linear inequality. Coach me up here. What will we do first? What will we do first? Mr. Coyne, what do you want to do first? Okay, so you're just going to take the 5 through. So we're going to multiply both sides by 5. So on our left-hand side, that gives me what? 3x minus 3. Can I do this? Can I go ahead and just in my head go 5 times 6 is 30 and then distribute the 30? So it becomes 30x minus 30. Is everybody okay with that? Then multiply both sides by 5 and distributed the 30 through. And then we're going to get all my x's on the same side. I don't care if you go, I'm going to subtract 30x or subtract 3x. Whatever you guys tell me to do. Okay? Eckert, what do you want to do? So he's going to subtract 3x is -3 less than 27x minus 30. Then he's going to add 30. So it gives him what? 27 less than 27x, which gives him x is greater than 1. I would rewrite it as x is greater than 1. Everybody agree with that? Now, we're going to rewrite it in interval notation. I'll help you out here. Let's go to the number line first. That'll help you. Here's 1. Give me the number to the right and to the left of 1. So 0 and 2. And I'll help you out. It's a parenthesis, and then I shade this way. Okay? What would that look like then? Because I need this written in interval notation. How would I write that? What's your name? Arav. Arav. What do you got for me?
The exclusive parenthesis, and then 1, and infinity.
And infinity is always exclusive. You can never be inclusive. You can never reach infinity. Once you get to infinity, add 1. Okay? So look here. This is how you would read this. Exclusively 1 to infinity. Inclusively would be the bracket. Questions? All right, let's go to the next one. So I ask you to solve this one. What would be our first step? I need to learn your guys' names. Hey, what's up, Mr. Riley? Hey. Here we go. Gosh darn, I'm going to have to do this. I'm going to have to be rude and point. Zhang that told me she submitted something in the Canvas that didn't. What's your first name? Nicole, it wasn't submitted, was it? No, okay. Nicole, what's the first step?
Distribute -2 to x minus 3.
Okay, so we have -2x That becomes plus 6 less than or equal to negative 2x plus 6. So we see what's happening here, don't we, guys? Let's finish it through, though, please. We're going to add 2x to both sides. So now I have 6 is less than or equal to 6. Okay, question. Is that true?
Yes.
Yeah, it is. If it was 6 less than 6, would that be true? No. But that is true. I could have plugged anything in for x, and I would get a true statement. So my answer is all real numbers. But how did I say to write it in interval notation? First name again? Andrew?
Exclusive parentheses.
You don't even have to say it for what you're going to say.
Okay, negative infinity, infinity.
Yep, negative infinity to infinity. You don't even have to say the exclusive for infinity. It's assumed, we know, you can't be inclusively infinity. From negative infinity to infinity. Okay? How do you graph that? Okay, it's going to get crazy. I don't care. It's going to get ready. I'm going to highlight it because I'm really good at graphing this one. There you go. That looks pretty good. All right? You don't have to do it. You don't have to graph it. Okay? It's everything. Questions? I thought I saw a hand pop up. Yes. Genevieve?
Yeah. Why would the first infinity be negative?
Well, what would the first infinity be? You want to go from positive to negative? Think about it. Don't we go from left to right? What's the furthest number to the left that you could possibly have on a number line?
A negative number.
A negative infinity to infinity. Okay? Don't let Buzz Lightyear confuse you to infinity and then beyond. We're going from negative infinity to infinity. All right? Did you guys like the Toy Story 4? Was it good? I liked it. I thought it was one of the better ones this summer. Who saw it? Did you guys think it was one of the better ones? I thought it was good. I thought it was good. Who was disappointed? Okay. You were disappointed? Which one did you like the best? So I liked the 3. I thought it was cool that the cute purple bear was like the godfather of the daycare. I thought that was cool. What was his name? Lotso? Lotso? Well, there you go. All right, so now we're going to solve a compound inequality. So coach me up here. Here we go. Mr. Lyon, what would be my first step? What? What?
Make it into two inequalities.
No. Okay, yeah, okay. We're going to hit pause. And what should we do to both? What should I do? Or is that just going to mess you up? It is? Here, I'll help you guys out then. Who is trained to write it as two inequalities? Who are my people trained? Okay. Who's like, no, the teacher said we could just leave it as one inequality. Okay. All right. Subtract 6. Whoa, I got my highlighter on. There we go. Subtract 6 to all 3 parts of my inequality. So now I have 2 less than or equal to 2x less than 8. Doesn't that seem so much easier? Then what? Divide by 2. And you don't even have to show these steps. I'm just doing it because you guys feel a little uncomfortable. So x, watch me read this. X is greater than or equal to 1 and less than 4. That's what that means. X is greater than or equal to 1. See how I read it? X greater than or equal to 1 and less than 4. Everybody agree with that? Now, look how nice it is to leave it as one inequality when I go to write it as an interval notation. Inclusively 1 to 4 exclusively. Here's 1. To the left of 1's 0. To the right of 1's 2. 3, 4, 5. Here's 4. Parentheses. Here's 1. Bracket. Everything in between. Are we good on the bracket being the inclusive because it's equal to, whereas the 4 is parenthesis because it's not equal to? Swango.
Well, I was just going to ask, how do you want us to graph it?
I didn't. Somebody else did. No, it wasn't me. All right, so now I have an or. Okay, I want to point out to you guys, I hit pause every time I tell stories, just so you know those stories aren't on the Canvas video. So, all right, I'm going to remove all evidence. All right, here we go. So we're just going to solve these separately. So here we go. We're going to add 3, so 5x less than or equal to 13. So x is less than or equal to 13 fifths. Everybody agree with that? And over here on the right, we have this or x is greater than or equal to 4. Okay. Now, we're going to rewrite, well, let's make sure we establish this. 13 fifths is what? 2 and 3 fifths. Okay. So if I graph that, so this is how I would do this one. Here's 13 fifths. 2 and 3 fifths. Over here is 4. So you know how I would do this? Since this is 2 and 3 fifths, I'm going to put 2 and 3. I want the whole number on each side of it. Cool? I probably should have put the 3, and there's a big jump there. That's okay. All right, so now, look, x is less than or equal to 13 fifths would be this. This way, I'm going to highlight it for you. How about that? That's the ugliest color to hide. Can I pick a different color? What color do I need to go with here? How about blue? Let's see if blue looks better. There we go. Or x is greater than or equal to 4 would be this, shaded to the right. How'd I do? Okay? We're not done yet, though. What do we need to do? We need to rewrite it in interval notation. Is that what you're asking?
I'm just kind of confused at why you choose brackets or parentheses.
Why does somebody coach them up? Help them out. Not me. Somebody else take it. Why do I know those are brackets and not parentheses? What's your name? Jessica, go.
So like the brackets are when it's
It's equal to.
and then it's a parenthesis when it's not equal to.
Bingo. Good? All right, so now when I write this as a interval notation, well, does anybody think they can write this in interval notation? I'm really bad. I'm sorry. I've already asked. And you had answers last time. What is it again? Andrew. What do you got for me? I'll help you out. I'll help you out.
Negative
Wait, no. I'm just going to give you the stylus. Let's see what you have. There you go. You're just going to write it. And then if it's bad,
That's fine.
I'll hit. It's not easy to write on that. I remember when they first got us the iPads as teachers, and we did this, and I was like, I'm learning technology. I'm going to get this, and it was like crash and burn. Like I broke my first iPad because I threw it. I was so frustrated. So frustrated. I got it now, though, finally. Okay. Oh, we need to let's go with the 8th grade posse to the boards. Let's go. Go find a place on the board. There's 6 markers, so only 6 of you are going to be writing, but you're all up there. Go find a place and you guys can write. Go, get up. You're still helping. There you go. You guys join forces. There you go. Everybody else, what are you doing? You're solving at your desks. I'm going to harass you guys too. This thing, they let me teach calculus and so forth. If I even took the time, look here, to rewrite it with the variables on the left. I recommend, after you're done solving, I recommend that. Now, I recommend as your next step to graph it before you write your answer in interval notation, because this is a unique situation. I heard you already saying it. I recommend graphing it next to see it. Because you're going to answer, you haven't answered Jack yet. Well, first of all, you got an and written. It's an or, but this is a unique or. So one of you up here, here's 3. Y is greater than or equal to 3. Or 4, 5, 6, 7. Y is less than 7. Now I have a question. If I go to the restaurant and I say, I want the steak or the chicken, the waiter only has to bring me one of the two to satisfy my order. Yes? Okay? I didn't say steak and chicken. If I said steak and chicken, the waiter has to bring me both to satisfy my order. Everybody agree with that, right? So this is this or this. Well, I graphed that second one wrong, didn't I? Oh my goodness. Oh my goodness. I was doing so well being eloquent. Or this. The correct answer is back there in that corner. It's all real numbers. Negative infinity to infinity. It's not an and. It's an or. Got a question. Pick any number. Pick any number. Give me a number. 12. Is 12 less than 7? No. But is 12 greater than or equal to 3? I satisfies the compound inequality. Any number up there would satisfy this inequality. That's why this answer is a solution. Okay? Now this is an and. So let's solve for x real quickly. So I divide by 3, I get x greater than or equal to 0. And I'm going to go ahead and put the intersection symbol. Let's do this in our head, can we? Can we do this in our head? Add 1, divide by 4. X is less than or equal to, what is that, negative 2? Okay? Sophomores. I won't make you get up to the board. Well, I tell you what, let's just all graph it. Let's just all graph it together. If we graph it, we'll see it. Here's 0. Here's negative 1. Here's negative 2. Here's 1. Let's graph it. X is greater than or equal to 0 is this. Agree? X is less than or equal to negative 2 is this. This is an and. Okay, look at me, sophomores. Who's my sophomores? Raise your hand. Okay? Cook, right? Miss Cook, what do you think the answer is? It's not that. It's not this. Look at the graph. No solution. We're going to write you could write it like this. Let's write like this. It's an empty set. That's interval notation. There's nothing. There is no number that's going to satisfy this compound inequality because it has to satisfy both parts. You agree with me on that? You guys getting the hang of it? Okay. All right. We're going to skip that one because it's easy. I'm going to put my homework up there. So be very clear. Look up here. These are the odds. Do all these. These are the odds. Do all these. Everybody clear on that? I didn't tag the odd at the end of those. Okay? There will be, make sure you're checking your solution key because there are going to be some that are going to, you're going to have to think with this interval notation. I'm going to give you a quiz over it. When I see you guys on Thursday, I will answer questions over the homework beforehand. If you're going right now, you know what?